Hey everybody, welcome back. So today I'm going to be doing a quick tutorial on how to use the Bridge Designer software. We used to call this the West Point Bridge Builder software, but they have since changed their name to just Bridge Designer. So this is a great program for experimenting with how different structures can produce different forces, and how you can support different weights using different style of structures. So on your computers, go ahead and open up the Bridge Designer software, and we're going to create a new bridge design. And then press OK. And then none of this stuff I really read, so we're just going to click Next and then Finish. And then it'll take you to our Bridge Designer software. So there's a couple things. The first thing is the goal of this software is to create the highest strength bridge for the lowest cost possible. So up here, you can see it gives us a dollar amount. And this is how much it would cost for us to build our bridge. And as I start adding things, we're going to see this cost go up. So if we use a thicker steel bar, if we use more joints and more members, our cost to produce this is going to go up. If we use a different type of material, our cost is going to go up. So the goal is to mess around with the type of steel, the type of tube, and the size or thickness of the bar, to see how cheap we can make this bridge while still having it function. Now, what I would recommend doing is I would just pick, a middle ground option for the size of the bar, and start with carbon steel and see how it goes. You want to try to challenge yourself at first with some smaller and some cheaper metals to see if you can do it. But generally, if you go this way, you are going to have to build quite a bit more. Usually, you end up building down here as well, as opposed to just picking a really expensive steel bar right off the bat. So in order to draw a bridge, we need two things. We need joints and members. There are already a couple of joints down here. But if we want to draw anything up here, we also have to add more up top. So you can do joints, members, select, and erase. I'm going to stick with the joint tool right now. And I'm just going to go every joint. I'm going to place one directly on top. And then I'm going to switch to my member tool. And then you just click and drag between the joints to make members. Now, remember in the presentation that I have posted on bridge design, one of the key aspects of bridge design is we don't want rectangles. Rectangles are bad. Rectangles flex, right? We want triangles. So what you can do is you can, every time you have a rectangle, just add a diagonal member to it. And this is our middle one, so I'm just going to do both. Just add a diagonal member to it because remember, we like triangles. We do not like squares. So I drew my first bridge, and now you can see this has a cost of over $1 million to build this simple bridge. I think that's because my steel bar is pretty thick. So what's cool about this is now we can test it too. So hitting this blue button up top, this will simulate a truck going across the bridge. And you can see that this bridge design worked at first. Now, something you want to keep in mind is that you want this to be as symmetrical as possible. So you see how on this side I have them going this way, and then this side I have it going this way, and then in the middle I have both. Symmetry is really important in bridge design. If I don't know if this is going to work, but if I get rid of that and then I test it, it's going to say my model is unstable. Okay. So you want to make sure that everything is as symmetrical as possible. And if you get that error, something isn't symmetrical or something isn't right. All right. So now I know that this bridge works in my simulation. So I'm going to change to my select tool. I'm going to change everything. And what I'm going to do is, so I'm at 1.1 mil right now. I'm going to reduce the size of this bar. You can see my cost went down to 600K. Now I'm going to test it. And I'd be willing to bet that this bridge is going to fail. Yep, just like that. So for reference, the red beams, those are under compression. The blue beams, those are under tension. Compression means they're getting pushed together, and tension means they're getting stretched apart. And if we remember from our bridge design principles, the top is more likely to experience compression, and the bottom is more likely to experience tension, getting pulled apart, right? So the goal of this software is how low can you make this cost while still using this bridge here? And the easy way to do that is obviously just make the beams thicker, but I want you to play around with the thickness of the bridge and then really focus on the structure. If it fails at first, try playing around with some different geometry and see if that gets you a better result. Because if you can improve your geometry, you can end up using thinner beams and get a lower cost bridge. Right? So that's the basics on how to use this software. Go and experiment.